Equivalent fractions are fractions that look different from each other, but are worth the same amount. So, easiest example I can think of would be the fraction 1/2. 1 is half of 2. So, equivalent fractions to 1/2 could be 2/4, 3/6, and so on. Now, with these, it's very easy to see. 2 is half of 4, 3 is half of 6. But it's not always going to be that easy. So we need to be able to come up with a way that we can create equivalent fractions from anything. And here's how we're going to do it. Let's take a fraction such as 5/7. 5/7 isn't as easy to create equivalent fractions from just based off of sight, but if we follow the simple rule of multiplying the numerator and the denominator by the same factor, we can create any equivalent fraction to 5/7. So let's say we wanted to multiply the bottom by 2. Well, 7 times 2 is 14, and if we've multiplied the denominator by 2, we also need to multiply the numerator by 2. So 5 times 2 gives us 10. 10/14 is equivalent to 5/7. And we can do this with any other factor. Let's say instead of 5/7, we now have, let's go with 22/33, something bigger. Well, if we once again multiply our numerator and denominator by the same fraction, or not fraction, by the same factor, let's go with 3 this time. 22 times 3, oops, hold on, let's use a different color. 22 times 3 gives us 66. And 33 times 3 gives us 99. So 22/33 is equivalent to 66/99. Different looking fraction, same value thanks to our multiplication. If we multiply by a different number on the top than we do on the bottom, our fractions are no longer going to be equal. And what's great is we can use this to solve problems. So let's say we're given this fraction. 5/9 is equal to something over, let's say, 27. Something 27ths. Well, if we can figure out what we multiplied the denominator by, we can figure out what to multiply the numerator by. So what are we going to multiply 9 by to get 27? Pause the video, see if you can figure it out. Alright, we're going to be multiplying by 3. So 9 times 3 is 27. So if we multiply 5 times 3, we will get our equivalent fraction. And our equivalent fraction ends up being 15/27. And not only can we do this way, but we can also go the other way. Let's say we have, let's go with 25/40. And this is going to be equal to something over 8. Well, we could divide, but if we don't know how to divide yet, we can just think of it backwards. 8 times what gets us to 40? Well, it's times 5. So now we have to think what times 5, it's a terrible looking arrow, sorry, what times 5 gets us 25? And if we know our multiplication tables, we will know that it is 5 times 5 gets us 25. So those are equivalent fractions, fractions that look different but are equal in value, and as long as we multiply our numerator and our denominator by the same factor, we can create equivalent fractions for anything.